Good morning, my little mathematicians. Today, we are going to review decimals before our unit test. I'm going to first go through and do all the odds with you. Remember, it's good practice to try them yourself first, so at any point in time, feel free to pause the video, try the problem, and then unpause it and come back and join us. Okay, so I'm going to start with number one. Again, if you want to pause it, that's fine, and then unpause it and come back and check with us. When you're adding, you want to make sure to line up your decimal. So I like to put the decimal right underneath the first one, and then 28 is to the left of the decimal, 42 is to the right of the decimal. Okay, I'm going to go ahead and put a zero placement holder right there so that everything's nice and neat and lined up and in the proper columns. When you're subtracting, 475 would have to go on top. When you're adding, it doesn't really matter as long as your decimals are lined up. Okay, I could have had 28 on top of the 475. Let's go ahead and add down. 0 and 2 make 2. 3 and 4 make 7. Don't forget to bring down your decimal. 5 and 8 make 13. And then 8 plus 2 is 10. And 1 plus 4 is 5. So your final answer is 503.72 or 503 and 72 hundredths. Again, it's always wise to sometimes double check your work that it makes sense. So 475 plus 30-ish should be around 500-ish. So that answer makes sense. Okay, let's go ahead and try the next odd, number 3. Now, when you're adding, it doesn't matter which one you put on top, but when you're subtracting, whatever comes before the subtraction sign goes on top, and whatever comes after the subtraction sign goes on the bottom. Okay, so line up your decimal. 5 is to the left, 94 is to the right of the decimal, and let's put a zero placement holder. If this were in a word problem, it's not whichever one comes first that goes on top. It's whatever whole number is bigger. So 18 is bigger than 5, so 18 would have to go on top of 5. Okay, just wanted to make sure we covered that. And now let's go ahead and subtract. Well, you can't take 4 from nothing. So let's go next door and borrow. That 2 now becomes a 1. And now I can add 10 here. So 0 plus 10 is 10. Minus 4 is 6. I can't take 9 from 1. So let's go next door again and borrow from the 8. That becomes a 7. And I'm going to add 10 to that 1. So 1 plus 10 is now 11. Minus 9 is 2. Bring down that decimal. And you can do 7 minus 5 is 2, and 1 minus nothing is 1. So your final answer is 12.26 or 12 and 26 hundredths. When you're multiplying, you just want to put the one that has the most number of digits on top. So this is made up of 2 digits, 0.44, and this is made up of 2 digits, 3 and 8. Okay, and just to refresh your memory on digits, like this one has 3, 1, 2, 3 digits, and that one has 1, 2, 3 digits. Okay, so since these both have 2 digits, it doesn't matter which one you put on top, and you don't have to line up your decimals when you're multiplying. Okay, that's only when you're adding or subtracting that you line up your decimals. When you're multiplying, you kind of ignore the decimals at the beginning. I just count that there's 2 numbers after the decimal here, 1 number after the decimal here. So I know that there's going to be a total of 2 plus 1 is 3 numbers after the decimal in my answer. And then after that, I just multiply like normal. I go 8 times this number, then times that number. I need to put a zero placement holder because, again, we're kind of ignoring the decimals. And I then move to the tens place. So I put a zero placement holder to move on to the tens place now when I start multiplying. And you go this times this and this times this. So let's go ahead and start. 8 times 4 is 32. 8 times 4 again is 32, plus 3 is 35. And then again, I used up that 8 and I'm moving on to the number that's, if that decimal wasn't there, in the tens place. So put a zero placement holder so that now I'm starting in the tens place. And then 3 times 4 is 12. 3 times 4 is 12 again, plus 1 is 13. Now go ahead and add down. You have 2, 7, 6, and 1. Okay, and we said we wanted 3 numbers after the decimal. So 1, 2, 3 puts us right there. 1.672. For my next one, we're dividing. Whatever comes first always goes inside the house, and whatever comes second goes outside the house. Now, when you're dividing, you can't divide with decimals, so I need to get rid of it in the divisor. So I'm going to move it over once in the divisor, which means I need to move it over once in the dividend as well. And then let's go ahead and rewrite it. Now I have 4 into 150, or not 150, but 15.2. Okay, so I move the decimal here, which means I move the decimal here. So now it's 15.2. Before you forget, go ahead and bring that decimal up in your answer in your quotient. Okay, and then you just divide like normal. 4 can't go into 1, but it can go into 15 3 times. 4 times 3 is 12. When you subtract, you get 3. Always double check that this remainder is less than the number you're dividing by right here. Like if this was a remainder of 5, that's bigger than 4, so I would have to erase this and try again, okay? But the remainder is smaller than this, so I'm good to bring down my next number of 2, and 4 goes into 32 8 times, and it goes in exactly evenly, so I'm done. My answer is 13.8. Okay, we did all the odds on the first page. Let's go ahead and turn the page to our next page, and now we're going to try these odds. Up at the top, number 9 says, Heather had $10 when she went to Target. When she got back home, she had $6.23. How much did she spend at Target? Well, first of all, this is definitely a different Heather because she has self-control. How can you spend that little amount of money at Target? Not possible. In order to figure out how much you spent, you take how much you had and you subtract how much you have left. Line up your decimals because you're subtracting, and that will tell you how much you actually spent there. Okay, let's go ahead and do the subtraction problem. You can't take 3 from nothing, so let's go next door and borrow, and that becomes a 9. Since there wasn't really anything there, we need to go next door again and borrow. That becomes a 9. And there wasn't really anything there, so let's go again next door, borrow. 1 less than 1 is 0. Now I can add 10 to this number. 0 plus 10 is 10. Minus 3 is 7. And 9 minus 2, also 7. 9 minus 6 is 3. And 0 minus nothing is 0. So that means that this Heather spent only $3.77 at Target. She should win a reward. Talk about self-control. Okay. During a family road trip, the Robertsons traveled 63.49 miles in the first hour. In the second hour, they hit traffic and only traveled 14.7 miles. That second hour was sad. Okay, how many miles were traveled in those 2 hours? I want to find the total distance that you went in those 2 hours. So what do you think I should do? Hopefully you said add. Line up your decimal. Hopefully they have like DVD players or something in there to keep them entertained in this second hour. Okay, so they barely traveled anything this second hour. Make sure your decimals are lined up. Put that 0 as a placement holder and then just add down. 9 and 0 make 9. 4 and 7 is 11. Bring down your decimal. 1 and 3 is 4. 4 and 4 make 8. And 6 and 1 make 7. So they went a total of 78.19 miles in 2 hours because that second hour, they did hardly anything, stuck in traffic. Those poor people. Okay. Number 13 says Talia has 72.4 feet of string and wants to make friendship bracelets to sell at the craft fair. If each string needs to be 0.8 feet, how many friendship bracelets can she make? Go ahead and try to think what operation you would do. Add, subtract, multiply, or divide. You have this much material. You're trying to figure out how much you can make if each one requires this much. Hopefully you said that you should divide. So you take the total amount you have and divide it by how much you need to make each one. And again, when we divide, we can't divide with decimals. So move it over and then move it over here as well in the dividend. Okay, and now my new one is 8 into 724 once I move the decimals. Okay, so 8 can't go into 7, but 8 can go into 72 9 times, and 9 times 8 is 72. When you subtract that, you get 0. Go ahead and bring down your 4. Now 8 can't go into 4. So it is true that you can add a decimal and a 0 to bring down another number, because 724 is the same thing as 724.0. But I can't bring down this 0 just yet. You can't bring two things back to back. So first, how many times did 8 go into 4? It goes in 0 times. It can't go in. Just like I said, 8 can't go into 7, and I put a 0 above it. 8 can't go into this 4, so I put a 0 above that number. And 8 times 0 is 0. When I subtract 4 minus 0, I get 4. Now I can bring down my next number. Okay, so you can't bring two right back to back. You need to at least do something first. Okay, now 8 can go into 40. Now that I brought down the next number, it goes in 5 times. See how that 5 is right above this 0 that I brought down. And 8 times 5 is 40. I get a remainder of 0, so I'm done. I can do 90.5 bracelets. Who wants to buy 0.5 of a bracelet? Okay, that would only go halfway around your arm, so there'd be nothing on this side to latch it to. It would just fall off. It would be useless. So I can't make half of a bracelet. So is it 90 or 91? How many bracelets can I actually make? Well, a lot of you guys are saying, oh, 0.5 tells you to round up, so it's going to be 91. Okay, now if we were talking about a basic, just normal division decimal problem, yes, the rules of rounding say 0.4 below tells this to stay 90. 0.5 or above tells this to round up to 91. But we're talking about a word problem, so we have to use our brains a little bit here and think harder about it. Do you have enough material to make 91 bracelets? No, you do not. You only have enough material to make 90 and a half. So I can only make 90 bracelets. So those rules of rounding, the 0.4 below or 0.5 and above, those only apply to non-word problems. Okay, in word problems, we have to use our brains and try to think, does it go up to 91 or stay at 90? Okay, and each situation is just slightly different. Let's go ahead and move on to problem 15. Problem 15 says Greg's dog weighs 47.2 pounds. Laura's dog weighs 16.34 pounds. How much heavier is Greg's dog? What do you think? Add, subtract, multiply, or divide? Hopefully you said subtract, because how much more, how much further, how many more than, how much heavier. Those are all indications that we should subtract. You're trying to find the difference between the two dog amounts that they weigh. So 47.2, we're subtracting, so line up that decimal, which means 16 is to the left of it and 34 is to the right of it. We're subtracting. Let's go ahead and put a 0 placement holder right there. Okay, now you can't take 4 from nothing, so go next door and borrow. That becomes a 1. And now add 0 plus 10 is 10, minus 4 is 6. You can't take 3 from 1, so go next door again and borrow. 1 less than 7 is 6. Now I can add 10, because 10 plus 1 is 11, minus 3 is 8. Bring down that decimal. 6 minus 6 is 0. 4 minus 1 is 3. So the difference in the two weights is 30.86 pounds. And yes, the abbreviation for pounds is LBS. Makes no sense, but hey, I didn't make it up. Okay, number 17. A skateboard weighs 12.8 pounds and the box that it is shipped in weighs 0.8 pounds. If it costs 25 cents per pound to ship a package, how much would it cost to ship this item? And this is why it's important to get lightweight luggage, okay? Because if you have to pay per pound, you don't want an expensive piece of luggage, because that takes up half the amount, right? Okay, but we're talking about shipping. So the box is only 0.8 pounds, right? But the skateboard itself is 12.8. So I want to find the total amount that it needs to be shipped, and that gets 16. Bring down your decimal. 2 and 1 make 3, and bring down that 1. So it's a total of 13.6 pounds that needs to be shipped. Well, we said it's 25 cents per pound. So if it was only 1 pound, it'd be 25 cents. If it was 2 pounds, it would be 50 cents, and so on. What am I doing? I'm multiplying how much needs to be shipped by how much it costs to ship each pound. Do I line up my decimal? No, I'm not adding, I'm multiplying, right? So I can put 0.25 right there. Okay. Again, when you're multiplying, you kind of ignore the decimals at the beginning and you just include them in your answer. So there's one number after the decimal here, 2 numbers after the decimal there, for a grand total of 3 numbers needed in your answer after the decimal. Okay, and now that I accounted for those, just multiply like normal. 5 times 6, and then 5 times this, and 5 times that. 0 placement holder, 2 times 6, 2 times 3, 2 times 1. So let's go ahead and do it. 5 times 6 is 30. 5 times 3 is 15, plus 3 is 18. 5 times 1 is 5, plus 1 is 6. The 5 is all used up. Let's move on to the 2 in the tens place. So put a 0 placement holder. 2 times 6 is 12. 2 times 3 is 6, plus 1 is 7. And 2 times 1 is 2. Go ahead and add down. You have 0, 10. 1 and 6 is 7. 7 and 7 is 14. 1 and 2 makes 3. And we need 1, 2, 3 numbers after the decimal. We're talking about money, so just 2 numbers after the decimal needed. That 0 tells that 0 to stay 0. So it's $3.40 to ship that item. Okay. Number 19 says 1 container of craft paint covers 1.1 square yards. Jillian has to paint the top surface of 3 pieces of wood for her craft project. One of those pieces is 0.4 square yards. The second piece is 1.55 square yards. And the last piece is 1.35 square yards. Okay, so you have 3 pieces, one that's 0.4 square yards, second is 1.55 square yards, and 1.35 square yards. How many containers of paint are needed for her project? Okay, well, once I find the total amount of square yards to paint, 1 container will cover 1.1 square yards. So let's go ahead and first find the total amount that needs to be covered. So I have 0.4, line up your decimal because we're adding, 1.55, line up your decimal, and 1.35. Let's put a 0 placement holder there. Okay, add down, you have 10, and then 1 and 4 make 5, 5 and 5 is 10, 10 plus 3 is 13, 1 and 1 make 3, and bring down your decimal. So you have a total of 3.30 or 3.3 square yards or yards squared that needs to be covered. So then I need to divide the amount she needs to paint by how much 1 can of paint can actually cover. So the total amount needed to cover is 3.3. And I said that 1 can only cover 1.1 square yards. Well, when you're dividing with decimals, we need to move it over in the divisor so that there is no more decimals. And however many times you moved it in the divisor, move it in the dividend as well. So now you have 11 into 33, totally doable. 11 can't go into 3, but it can go into 33 3 times because 11 times 3 is 33. When you subtract that, you get 0. So it went in perfectly evenly. You will need 3 cans of paint to cover that much space. Okay. Again, hopefully we're pausing the video and trying things on our own, then unpausing and coming back. Okay, let's try this last odd problem. It says a water tank was leaking 2.3 gallons of water per minute. It took the repairman 15.2 minutes to stop the leak. How many gallons of water were wasted? Sometimes it's easier if we round them to whole numbers and then try to figure out what to do. So if I said a water tank was leaking 2 gallons of water per minute, and it took him 16 minutes, because we want something that 2 could go into in case we have to divide, or if we multiply, it's easy. If we add it, it's easy. If we subtract it, it's easy. Like, make nice, easy numbers to figure out. Okay, so if it was leaking at a rate of 2 gallons of water per minute, and it took him 16 minutes to stop the leak, how many gallons of water were wasted? Okay, well, per minute, 2 are being wasted, and it took him a total of 16 minutes to stop it. So how much water do you think was wasted? Hopefully, you figured out, give me 1 second, that it was about 32-ish, right? Because you did 2 times 16, because each minute, this much is being wasted, 2 is being wasted. And if it took 16 minutes, so the first minute would be 16, the next minute would be another 16, and so you would multiply those two numbers. We're going to do that same thing of multiplying 2.3 times 15.2. Sometimes just making them smaller, easier numbers to deal with that aren't fractions or decimals, suddenly it clicks of what operation you should do. Now, if doing that still doesn't help you figure out what operation to do, we can do this little trick. Okay. It says a water tank was leaking 2.3 gallons of water per minute, and it took the repairman 15.2 minutes to stop it. This 15.2 has 1 unit with it, minutes. This 2.3 has 2 units with it, gallons per minute. I always start with a thing that has 1 singular unit, 15.2 minutes. And then I use what I call my conversion unit, the one that has 2 units with it, gallons per minute. I use that to multiply with it. And I'm going to do this thing. Let's kind of flash back to fractions. Okay. If I were to have this problem and I was multiplying fractions, these two 7s would cancel out and become 1, right? Okay, because they're exactly the same. And so 7 divided by 7 is, like, you're like, oh, I can reduce these both by 7. 7 divided by 7 is 1, and 7 divided by 7 is 1. So when they're the same thing across from each other, they cancel out and become 1. Now, I know that these can cross cancel as well, but I'm not going to for just a second because I want to show you something. The two numbers that are across from each other get multiplied. So you have 8 times 1, which is 8. These two numbers across from each other get multiplied. 1 times 4 is 4. And when something's on top and something's on the bottom, this is saying 8 divided by 4. So there's several things from this basic multiplying fractions problem that I want you to take away. If something is alike diagonally across from each other, they cancel each other out. If two things are across from each other, they get multiplied. If one thing's on top of the other, it's the top divided by the bottom number. Okay? So I'm going to use that logic to help me with this problem. I want minutes to cancel, so I'm going to put that unit diagonally across from each other so that minutes can cancel just like the 7s canceled earlier. Okay, and this conversion rate right here, it says there was 2.3 gallons of water wasted per 1 minute. So 2.3 gallons in 1 minute. So here I'm multiplying by this singular unit, and I knew to put minutes here because I wanted them to cancel, and I'd be left with the units of gallons, which is good because I said how many gallons of water are wasted. So I ended in my unit of gallons. Now these two numbers are across from each other, so I'm going to multiply 15.2 times 2.3. Okay, just like I multiplied 8 times 1 because they were cross, and 1 times 4, they were cross from each other, so I multiplied them. Now, if it was 15.2 over 2.3, like if the 2.3 was down here, then I would have divided the two numbers. Okay, now that we've established setting that up, this is a way that you can see, okay, if the 2.3 ended up down here, I would divide these two numbers. It would be 15.2 divided by 2.3, but since they're across from each other, I know to multiply them. So if you can't just look at it and figure out if you should multiply or divide, here's another tool that you can use to figure out that we multiply these. Okay, 3 times 2 is 6. 3 times 5 is 15. 3 times 1 is 3 plus 1 is 4. Now that 3 is all used up, so I'm going to put a 0 placement holder to move on to the 2 in the tens place, if that decimal wasn't there. 2 times 2 is 4. 2 times 5 is 10. 2 times 1 is 2, plus 1 is 3. Go ahead and add down. You have 6, 9, 4, and 3. And there was one number after the decimal there, one number after the decimal there, for a total of 2 numbers after the decimal in my answer. Right there, it's between the 4 and the 9. So 34.96 gallons of water are going to be wasted, right? I can put it up there. 34.96 gallons of water are wasted. If you got those right, congratulations. Okay, these were some tough problems. Make sure to also try the evens. And again, when you go through the next video, feel free to always pause it, try it yourself, and then unpause it and check yourself. We're almost there, my little mathematicians. You're soon going to be masters of all operations with decimals.